Let's go through how to convert a number into a different base, k. For example, 11 in regular old base 10 is equal to 102 in base 3. Why is it equal to 102? Well, because we can write 11 like this. We can write 11 as the sum of a bunch of terms where every term has two numbers in it. It's got a power of 3, and it's also got a constant term that, in the case of base 3, is going to be either 0, 1, or 2. So how do we actually write a computer program to do this? Well, I Googled this, and I came to a Stack Overflow post, which had an algorithm that looked kind of like this. I didn't understand it at first, so my goal with this video is to go through and understand why this algorithm here works. So why does that algorithm work? Well, first of all, we just have to realize that any number that we have, we can write it as a sum of a bunch of terms where every term is two numbers being multiplied, where one number is an exponential to a number and the other one is a term. Just like in the last page we saw. For example, 11, we can write it in this way. In this case, we have, we're writing n in base k, so k is 3. So we replace everywhere we saw a k with the 3 here. And we count up successive powers of 3 until we are able to represent the number that we started with. So why is it important that we can write every number in that way? Well, once we've written our number in that way, all we have to do is just read off the coefficients, and that's our number in our new base. So if we can get our number into this form, then it's as easy as just reading off the coefficients to convert the number. So how do we actually read off the coefficients of this number? And it might seem like I'm jumping ahead because how do we actually get this number? Well, we don't have to explicitly actually convert our original number to this different representation of it. We just know that our number can be written like this, and because we know that that's the case, we can kind of pretend like we've rewritten it like this, and we just perform operations on it to read off these coefficients. So how do we do that? Well, one algorithm that you could come up with, there are many different ways to do that, but reading off the coefficients, we could do it like this. We could read off the rightmost coefficient and then save that somewhere, and then shift these terms down to the right one and bump off the last term, and then do it all over again. So how might we go about doing that? Well, one way that we can read off the rightmost coefficient in the sum of a bunch of terms like that is we can use the modulus operator. So let's use our running example of 11, and let's do mod 3. So recall that 11 can be written in this form right here. And if we do mod 3 of it, then mod is distributive over addition. So the mod gets applied to each of these individual terms. And notice every term except the last term is going to go to 0 because mod says, give me the remainder when divided by 3. Each of these terms except the last terms has at least one factor of 3. So those are going to be evenly divisible by 3. So those are all going to be 0. But the last term doesn't actually have a factor of 3 by definition. This number that's being multiplied by this power of 3, all these power of 3s, they're 0, 1, or 2. So it definitely can't have a factor of 3. So when we take the mod, that has the effect of isolating that last term. And that's how we can read off the rightmost coefficient for a number, say 11. Now, how do we shift those terms downward and discard the right term? Well, we can just use division, actually, and let's see how that works. So let's take 11, and recall again, we can write it out in this way. If we divide it by 3, then we can distribute we can do division over this addition up top and rewrite that expression as the sum of three divisions going on here. And if we carry out these divisions on each of these terms, then what's going to happen is every term except the rightmost term, the power of 3 is just going to get bumped down 1. So this was 3 to the second power before, but when we divide it by 3, it just goes down 1 power, and it's still 1 times 3 to that. And this one is also going to get bumped down similarly. And I should have said we're doing integer division here. So since this number here has no factor of 3, it's actually less than 3. When we divide it by 3, 3 goes in 0 times evenly, so it's just going to be 0. Which results in exactly what we're trying to accomplish here, shifting these terms down rightward, and discarding the rightmost term. We can see that we've accomplished that here. We got rid of this rightmost term, and we're just left with these other terms here. So let's actually just do the full example out for 11. Here's how it goes. We start with 11, and we can imagine that it's written this way, because we can always rewrite a number like this. We're going to mod by 3, which is going to pop off the last term, extract the last term, and we're going to save that. We're then going to divide 11 by 3, and 3 goes into 11 three times evenly, and what recall that division is going to move these terms down rightward and bump off the last term. So these are our rightmost terms here. We take the modulus again, and we bump off the rightmost term, and that's 0. We divide again. Once again, shift all the terms to the right and bump off the rightmost. And we do a mod again, and we get that last term. And then we divide by 3 again, and we finally get 0, and we're done when it's 0. So now we've collected these terms, and we just have to read them off backwards, and we get 102. So the upshot is 11 in base 10 is written as 102 in base 3.